Hello friends, this video on application of derivatives part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 6. Now let's understand what are increasing and decreasing functions, and then we'll understand how derivative can be used to find increasing and decreasing functions. So in case of increasing and decreasing functions, we classify function as increasing, strictly increasing, decreasing, strictly decreasing, and neither increasing nor decreasing. So there are 5 classifications actually. A function can be classified into these 5 buckets. Let's understand what is increasing function. So a function that continuously increase. For example, this function, if you see, it's always increasing, right? It's always increasing. So this kind of function is called strictly increasing function. Sorry, this is strictly increasing function. Strictly increasing. So I took this part. Now I'll take increasing function. Increasing function is that kind of function which increases in particular area, and in some area it is constant. For example, this kind of function, if you see, right, it is not decreasing though, but it is not increasing everywhere. For example, this function, if you see, this is increasing from here to here, from this zone from here to here, it is constant, and from here to here also it is constant, but sometimes increasing and sometimes constant. So that kind of function is called increasing function. Similarly, decreasing function, I'll take decreasing function now. Function which decrease sometimes constant, sometimes decrease, sometimes constant. This kind of function is called decreasing function. Correct? Then we have strictly decreasing. That means the function which always decrease. There is no constant value. There is no interval where it is constant. Always decrease. That's called strictly decreasing. Please note, strictly decreasing. It has to decrease always. And then there are functions which are neither increasing nor decreasing. For example, this kind of functions which increase and then decrease. So we have some time interval where it increase, some time interval where it decrease. Such kind of functions are neither increasing nor decreasing. So if I have any function, I can classify that function, or I can put this function in one of these buckets. Correct? So this is the definition of increasing and decreasing functions. We have various practical application of these kind of functions. In terms of physics, when we have the function, you want to understand the pattern, we need this. In the world of you can say accountancy, maths, where commerce, where we have some pattern, the flow pattern of the sales and all, where you want to see where is the pattern of the sale, where it is decreasing, where it is increasing, or strictly increasing, strictly decreasing, such kind of thing, place where we use this kind of function, increasing and decreasing functions. So this is what the practical application of increasing and decreasing function. Now let's understand how can we use derivative to find whether a function is increasing, strictly increasing, decreasing, strictly decreasing, or neither increasing or decreasing. Before we understand the application of derivative in finding increasing and decreasing function, let's have a formal definition of increasing and decreasing functions. A function is called increasing function. Please note this increasing if you take any point x1 and x2, where in this graph, let's suppose you have 2 points x1 and x2. You have this kind of graph. You take any point where x1 is less than x2, that is x2 is greater than x1. Then this value, that is f of x1, has to be less than or equal to f of x2 for any point. So if you see the earlier graph which we plot, for example, in this graph also, this graph, let's suppose, is an increasing function. So if you take these 2 points here, f of x2 is greater than f of x1. But if you take these 2 points, f of x1, let's suppose this is x1 here and this is x2 here, then f of x1 is equal to f of x2. So you have two conditions, either f of x1 is equal to f of x2 or f of x1 is less than f of x2. So if either of these condition is there, then this function is called increasing function. Similarly, for strictly increasing function, if you take any 2 points, then f of x1 has to be less than f of x2. It can't be less than equal to. such kind of function is like this, if you see, correct? It has to, this guy, if this guy is x1 and this guy is x2, this point, and this point is x2, then f of x1 has to be less than f of x2. Similarly, we have strictly decreasing function. So, and also we have decreasing function. So let's understand both. So we have this function, and this guy is, let's suppose, decreasing function, where some part is equal, some part is decreasing. So in this case, it's other way around. If you have 2 points, let's suppose here x1 and x2. So in that case, it says f of x1 has to be greater than or equal to f of x2. In this case, if you see, both are equal. But if you take these 2 points here, x1 dash and x2 dash, in this case, f of x1 is this and f of x2 dash is this. And if you see here, f of x1 dash is more than f of x2. So either of these is true, greater than or equal to. So it is decreasing. In case of strictly decreasing function, like this, you take any points, x1 and x2, take any points, then you'll find that f of x1 has to be more than f of x2. There is no equal to thing here. It is always f of x1 is greater than f of x2. This is nothing but a mathematical definition of increasing, strictly increasing, decreasing, and strictly decreasing function. Let's now understand the derivative of. Now let's understand the criteria for increasing and decreasing function. So if I say x0 is a point on a function, on the domain of the function, for example, this is my function, and if you see y is my range and x0 is a point in the domain of a function, then I say f is said to be increasing, strictly increasing, decreasing, or strictly decreasing function if there exists an open interval. There has to be an interval, correct? For example, from here to here, there has to be an interval, and that interval should contain this guy x0, such that this function is increasing, strictly increasing, decreasing, or strictly decreasing in that interval. So the first criteria is there has to be an interval. There has to be an interval. There has to be an open interval. So when you say the function is increasing or decreasing, we generally talk about in an interval the function is increasing or decreasing. Correct? Let's take some examples. We have to show that this function fx is equal to 7x minus 3 is strictly increasing on R. So the rule we have, as we have understood till now, is if you have this function and the function is strictly increasing, and you take any point x1 and x2 where x2 is greater than x1, then my f of x2 has to be greater than f of x1. Correct? If this is true, the function is strictly increasing. You know this? So let's take, let x1 and x2 be 2 points R, because my R is the interval here, and I say that x2 is greater than x1. Let's find f of x1. F of x1 is nothing but 7x1 minus 3. Why I am finding this? Because I have to prove that f of x1 has to be greater than f of x2. Sorry, f of x2 has to be greater than f of x1. So to prove these two are this two hold this relationship, I have to first find f of x1 and f of x2. Similarly, let me find f of x2. So that is nothing but 7x2 minus 3. Now I have to prove that f of x2 is greater than f of x1. So let's do a rough calculation here. So f of x2 is nothing but 7x2 minus 3, and this is greater than 7x1 minus 3, correct? 3 cancel, 7 also cancel. So I can say that x2 is greater than x3. That is, sorry, x2 is greater than x1. And that is true, we know. Correct? So what we can do is we can follow the reverse engineering way. We can't assume this, right? Or we can say that let's assume this is true. And we can, with that, I'll prove a statement which is true. We can say that our assumption was true. That is one approach. Or I can take this guy, I can multiply this guy with 7 both sides, subtract with 3 both sides, and whatever I get, that becomes f of x1 and f of x2. So let's do that way. We can say that x2 is greater than x1, we know that. Multiply both sides by 7, you get 7x2 is greater than 7x1, correct, because 7 is positive. Subtract both sides by 3. So this becomes 7x1 minus 3. Why I'm doing this? Because this guy will become f of x2 and this guy becomes f of x1. Correct? So this is what I have to prove, and I have proved this. Since this was true and I have proved this, it means that my fx is strictly increasing. Very simple. See, I did the reverse way. I calculated in this fashion, and then in the reverse way I made, or I proved that f of x2 is greater than f of x1. If you want to make it simple, you can just say, let's assume f of x2 is greater than f of x1. Simplify this, and then you find this, and then you can say it will be other way around approach, and then you say, since this is true, our assumption was. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.